This is 3.3 day 1. We're going to be finding zeros of polynomials. As always, please pause often to get things written down and to try the problems and then come back to get some help or to see if you got the right answer. So number 1, it wants us to factor to find the zeros of that quartic. Now we've done a lot of factoring, but not as much with a quartic. A quartic factors the same way that a quadratic does. So we still want to see what multiplies to get negative 36 and what adds to get negative 5. So we're looking for those two magic numbers. And of course, those are negative 9 and 4. So just like we would with a quadratic, we're going to split the middle, but we don't have to since the leading coefficient's 1. So we can just jump straight to writing it into factors. So instead of writing just an x, we're going to write x squared minus 9 and x squared plus 4. So if we were to multiply this back out again, x squared times x squared would give us this x to the 4th. All right, now this x squared minus 9 is a difference of squares, so we can factor it again. The x squared plus 4 is a sum of squares, so we're not allowed to factor that one again. And since it said we're going to use factoring to find the zeros, after we get them all factored, we're going to set each one equal to 0 and solve. So x minus 3 equals 0, x plus 3 equals 0, and x squared plus 4 equals 0. So we have x equals 3, x equals negative 3, and x squared equals negative 4. So to get this last one completely solved, we're going to have to take the square root of both sides, which when you take the square root of a negative, you might recall that turns into an I. So we have x equals 2i, but also when we take a square root, we always have to have a positive and a negative version. So you have positive 2i and negative 2i. So these two that don't have the i's with them, these would be our x-intercepts. And then the two that have the imaginaries will not show up on your graph. But part of the reason we have 4 answers here is because we had it to the 4th power. So the degree tells you about the zeros. It means you can have a maximum of 4 zeros there. All right, let's try another one. I'm going to factor to find the zeros of this cubic. It has 4 terms, so every time we have 4 terms, we use factoring by grouping. So pause it, go ahead and factor by grouping, and then come back and check to see if you got it right. We did one of these in our last section, so hopefully it seems familiar to you. We first end up with x squared minus 9 times 3x minus 2. The x squared minus 9 can be factored again because it's a difference of squares. And then we will take each one of those factors and set them equal to 0. So x plus 3 equals 0, x minus 3 equals 0, and 3x minus 2 equals 0. So we have x equals negative 3, x equals positive 3, and x equals a positive 2/3. Now each one of these represents an x-intercept. So on this graph of this cubic, it crosses the x-axis 3 times with no imaginary zeros at all. All right, number 3, find a 3rd degree polynomial equation in standard form with zeros 3 and 4i. 3rd degree, meaning a cubic. Cubic means we need to have 3 zeros typically. If we have a 4i, that means there's also a negative 4i. Imaginary numbers always come in pairs. Last section we talked about how square roots come in pairs, a positive and a negative. Same thing with imaginaries, because it technically is a square root. How about that? All right, so let's put these into factors. We have x minus 3 times x minus 4i times x plus 4i. This is something that we did in the last section, 3.2, and wrote all of those as factors and then multiplied them out to get it into standard form. You can multiply any of them in any order, but I would recommend multiplying these last two first. So hit pause, try that out, and then come back and check to see if you got it right. So we have x squared minus 4ix plus 4ix minus 16i squared. The middle terms will equal 0, so they're going away. And then the I squared equals negative 1. So this negative 16 becomes a positive 16. We drop down that x minus 3 so that we can then multiply that out. So we're going to multiply all of that. So x cubed plus 16x minus 3x squared minus 48. No like terms to combine, but we can rewrite it so that it's in standard form. X cubed minus 3x squared plus 16x minus 48. It asks for an equation, so we need to throw in a y equals there. Otherwise, it's just an expression. And ta-da! All right, number 4 is very similar, so please try that. Start by writing your factors. Then multiply things out until it's all in standard form at the end. Hit pause, try it, and then come back and check. X plus 2 times x plus 6i. Since I see a negative 6i there, I know that there also is a positive 6i that has to be a 0. X minus 6i. I'm going to multiply these two together first. X squared plus 6ix minus 6ix minus 36i squared simplifies to x squared plus 36 after I turn the I squared to a negative 1. And then I drop down the x plus 2. I'm going to multiply all that out. I have x cubed plus 2x squared plus 36x plus 72. Make it y equals so that it's an equation. And we're done. Well, with that problem. We still have more to go. All right, next we're going to do something completely different. We will be listing the possible rational zeros of a polynomial. So switching gears here. So pause so you can write that down, and then you can listen to what we're going to do. With these, you are going to take your constant. This number here at the end that doesn't have a variable is called your constant. And we're going to use the letter P, don't ask me why, for the constant. We also are interested in the leading coefficient, so the number that's before your largest degree. Leading coefficient, and we're going to use the letter Q for that. So you're going to state your constant, which is P, and we have that as 12. And then our leading coefficient, I'm going to run out of room, which is Q, is 1. All right, then you're going to list out all of the factors of 12 and all of the factors of 1. So we're going to want positive and negative versions. So positive and negative, 1, 2, 3, 4, 6, 12. 1 is much easier, plus or minus 1. There's nothing else really that multiplies into 1. After you do that, you're going to take P and divide it by Q. So we're going to take each one of these p values and divide it by all of the q values. Well, in this case, dividing all of those by 1 doesn't change anything. So our p over q is positive and negative 1, 2, 3, 4, 6, 12. So the first part of the instruction said, list the possible rational zeros of the polynomial. That's what we just did here. We have 12 possibilities. Okay, some people say 6 because they see 6 numbers, but we have the positive and the negative version of those. So 12 different possible numbers. Now we're going to use those possible numbers to do synthetic division to find the zeros of the polynomial. Okay, so remember from when we did it before, if we do the whole synthetic division process and we get a 0 at the very, very end, that tells us that that number is a 0 or a factor of this. So that's what we're looking for. We're going to try to do the whole synthetic division and get a 0 at the end. Now I have some insider information, so I know good places to start, but when you don't know a good place to start, you just might have to start with 1 and then do -1, 2, -2, and keep going until you find them. Let's start with -1. So I'm going to write the coefficients across the top. 1, -3, 3, -5, 12. Oh wait, do you see how there is not an x term? So I can't jump straight to 12. Hopefully you remember that when there's a term missing, you have to put a 0 in as a placeholder. Okay, then we're going to go through the normal synthetic division process, where you drop the 1 and then multiply and add. So hit pause and go through all of that. When you get to the very end, you'll see that we got a 0, which is a good thing. If we got a number that didn't have a 0, we would eliminate it as a possibility. Now we started off with degree 5. That means all of these are coefficients of a degree 4, or a quartic. We're going to use these coefficients to divide another number. Let's try 2. So we're going to do synthetic division again, using these same numbers down here at the bottom. So again, hit pause, run through. When you came back to check, hopefully you got a 0 as well. Now notice what we did that time. We took a quartic, and now these are the coefficients of a cubic. So we went from a 5th degree to a 4th degree. Now we have coefficients of a 3rd degree. But if you remember from when we did synthetic division before, you've got to keep going until you get down to the quadratic stage. So we need to do it another time. And believe it or not, zeros can show up more than once. So we're going to use 2 again. Running through that process gives us another 0, which is again a good thing. And now these coefficients down here represent a quadratic. So this is our x squared term, our x, and then our constant. So let's write it as a quadratic. We would have 1x squared. There's no x term, so plus 3. And then we can solve that. So x squared equals 3. And if we take, a -3, take the square root of both sides, we get plus or minus I radical 3, because it was a negative. So putting everything together that we found, we know that x equals -1. We know that it equals 2 twice. And then it's also plus or minus I radical 3. Notice that we have 5 answers here, and we had a degree of 5 at the beginning. Okay, all of that kind of matches up together. These 2's here mean that your graph is going to have a multiplicity of 2. So it's going to bounce off of that 0 when it hits it. All right, last one. Very similar to number 5. So I want you to write it down. Start by finding your P and Q. Make your list of possibilities. And then use synthetic division to find out which ones actually work. All right, so -24 is our P value. 3 is our Q value. So we need positive and negative factors of 24, which man, oh man, there are a lot of those. Factors of 3, not as many, but more than what we had for our denominator last time. So when we take our P divided by our Q, we're going to take all of those top numbers divided by 1. But then we're going to take all of those top numbers and divide them by 3 as well. All of these divided by 3. If we get a number that's already on our list, we're not going to repeat it. So 1/3 is not on our list, so we'll add that to our list. 2/3 is not on our list when we take 2 divided by 3. But 3 divided by 3 is 1, and that's already on our list, so we're not going to state that again. 4/3 is new. 6/3 is 2, so we don't need that one. 8/3 is new. 12 divided by 3 is 4, already have it. 24 divided by 3 is 8, already have it. So I need to make my brace a little bit bigger because all of these are our possibilities. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2 because we have the positive and negative versions of that. So we have 24 possible zeros. All right, so we could use any of those numbers to start doing synthetic division with. I'll give you some hints though. Start with -4 and see how you do with that. So go ahead and write all of the coefficients across the top and then do your synthetic division. Since this is a quartic, we're going to have to do synthetic division twice to get down to the quadratic level that we want to be. So this first level will take us to a cubic. Then we need to pick another number. And I know you would probably never choose to pick this number on your own, but the next number is going to be 2/3. A -2/3. Now, obviously, if no one's telling you what numbers to use, you are just randomly picking numbers and trying them out to see if you get a 0. It is a little bit tedious of a process, but that's how you do it if you're not sure where to begin. All right, so these coefficients are for a quadratic, so we would have 3x² minus 9 equals 0. And then we're going to solve that. So 3x² equals 9, x² equals 3, so x equals positive and -3. So our final answer, our zeros for this quartic are -4, -2/3, and then positive and negative radical 3. And that is all for 3.3 day 1.